Hello students, welcome back to my channel. This is Harsh and today we will discuss class 12th maths exercise 2.1 intro, which is inverse trigonometric functions intro. Okay, so let's begin. The basic concepts which we have read in class 11th are basic concepts. Okay, sine is defined on sine function. I'm writing this cos function is defined on real numbers. Cos function here. Tangent function is defined on real numbers. Real numbers minus equals to such that 2n plus 1 pi by 2. This pi by 2 is one multiplication of 2n plus 1. Okay, and n belongs to integers. Now let's have a look at the cotangent functions. Cot functions. Cot functions. Cot are is defined on real numbers such that real number minus n pi n belongs to z. Let me write all of these so that for that pause the video to note it down. Okay, since I've written down the some basic concepts of class 11th, you need to memorize them. Okay, and if you want to learn how they are derived, go to class 11th video of trigonometrics. Now let's have a look at some other topics, but before that pause the video to note it down. Students, let's understand what are trigonometric functions. Inverse trigonometric function, basically inverse trigonometric functions. Okay, so what are inverse trigonometric functions? Some of you may be wondering that sine inverse x equals to 1 by sine x. No, this is not equal to 1 by sine x, because sine inverse x is a special type of function, and where sine 1 by sine x is not a function here. Okay, you can't say that sine inverse x equals to 1 by sine x. Okay, and if you write so, then your question will be marked as wrong. Okay, there are some principal values of inverse trigonometric function along with their domain and range. I'm making their table, so for that please pause the video for a while. And since before I make the table of this principal values of domain and range, let me tell you a few key points, which are: whenever no branch of an inverse trigonometric function is mentioned, we should consider the principal value branch of that function. Okay, whenever the value is not given of that inverse trigonometric function, we should consider as the principal value function. Okay, and apart from that, the value of an inverse trigonometric function which lies in the range of principal branch is called principal value of that inverse trigonometric function. Okay, let me write it down here. This was our first point. Our second point is The value of an inverse trigonometric functions value of an inverse trigonometric function metric function metric function which lies in range of lies in the of principal value range of principal branch is called principal values is called principal value of that inverse trigonometric function value of that function. I'm writing here function simply for inverse trigonometric function. Okay, you need not to be confused. Let me repeat this line. The value of an inverse trigonometric function which lies in the range of principal branch is called principal value of that function. Simple. The value of the value of inverse trigonometric function which is lying in this principal branch is called principal value of that function. Simple. And now let me make the table of that inverse trigonometric function, but before that pause the video, note it down. Okay, since I have made the table of the principal value branches along with their domain and ranges, so let's understand this table. What is this table? Okay, and apart from that we will cover some tricks to understand this table. Okay, these are the 6 inverse trigonometric functions. Let's take a sine inverse. Okay, sine inverse domain lies from -1 to 1. Okay, and its range lies from -pi/2 to pi/2. There is nothing conceptual in this table. Okay, what you need to do is you need to memorize this table. Okay, this is the domain section and this is domain, and this is the range of this 6 trigonometric functions. Okay, this is cos inverse 1. Cos inverse 1 range domain is -1 to 1 and its range is 0 to pi. Okay, cosecant inverse domain is real -1 1 subtracting from the real numbers, and its range is -pi/2 to pi/2 subtracting -0. Okay, we are subtracting 0 from this pi/2 to -pi/2 to pi/2. Okay, memorize these things. Okay, these are very important. Let's talk about secant inverse one. Secant inverse domain is real number -1 to 1 and its range is 0 to pi close bracket and subtracting -pi/2. Okay, tangent inverse domain is real numbers and its range is -pi/2 to pi/2, and cot inverse domain is real number and its range is 0 to pi with curly brackets. Okay, now let's have some tricks about to learn this. Okay, you will have to memorize this sine inverse and cos inverse domain and ranges. Okay, what we need to memorize is their ranges. Okay, ranges are asked many times. Okay, and apart from that ranges are also used in our questions. Okay, so let's say we need to memorize cosecant inverse and secant inverse ranges. Okay, simple method to memorize this are sine inverse. The opposite of sine inverse is cosecant inverse because you 1 by sine equals to cosecant. Okay, you may be familiar with this. 1 by sine equals to cosecant inverse. That's why -pi/2 and -pi/2 here is in this square brackets, and apart from that we have subtracted 0 from this. Okay, this was the trick to memorize this cosecant inverse. Okay, and cos inverse opposite is secant inverse, and its range is 0 to pi with these square brackets and subtracting minus pi by 2. Okay, we have subtracted minus pi by 2 from this 0 to pi. And for tangent inverse one, simply we can say that tangent inverse and sine inverse functions in inverse functions ranges are quite similar, but the difference is here the brackets are this curly brackets and the brackets in the sine inverse are square brackets. And last one is cot inverse. Cot inverse domain is range, and its range is 0 to pi. Okay, and 0 to pi is in this curly brackets, and in cos inverse these brackets are squares. Okay, you need to memorize this principal value. Okay, these are very helpful in questions, and apart from that these values are directly asked in some competitive exams. Okay, so memorize this, and now let's talk about some examples, but before that pause the video to note it down. Okay students, let's have a look at the example first of this 2.1 intro, which is find the principal value of sine inverse. Find principal value of principal value of sine inverse 1 by under root 2. Okay, we need to find out the principal value of sine inverse 1 by 2. Let's have a look at the solution. Okay, let sine inverse 1 by 2, sine inverse 1 by under root 2, 1 by under root 2 equals to y, and y belongs to pi by 2 to pi by 2 minus y by 2 to pi by 2. Okay, this was the range of the sine inverse function, okay, which I have written here, and let it be equals to sine inverse equals to y. And let's have a look at what will be the next step. Okay, take this sine inverse here. We have 1 by under root 2 equals to sine y, and what I have done is I have just taken the sine inverse which was in multiplication with 1 by under root 2 to the this other side. From here we get sine y. Okay, and if we see what is the value from on which value we get 1 by under root 2, and it is none other than the pi by 4. Okay, pi by 4 equals to sine pi by 4 equals to 1 by under root 2. Okay, sine pi by 4 equals to 1 by under root 2. Therefore the principal value is pi by 4 for this sine inverse 1 by under root 2. Okay, I know some of you may be there who didn't understand this question. What was I doing? Okay, let's have a look at this question once again. We need to find out the principal value of sine inverse 1 by under root 2. The very first step I have considered sine inverse 1 by 2 equals to y, and y is belonging from minus pi by 2 to pi by 2. This is what I have write down in the principal values. Okay, and if you look in the principal values, the principal value of sine inverse was minus pi by 2 to pi by 2 in this square brackets. And apart from next step, what we have done is we have taken sine inverse here from here to here. Okay, this is what you will get by taking the sine inverse from here to there. Okay, so you will get sine y. Now we have to look at which angle 1 by under root 2 value is present. Okay, and it was none other than pi by 4. Okay, so this was the principal value of sine inverse 1 by under root 2. Let's have a look at the second example, but before that pause the video to note it down. And student, what was the meaning of this? Its meaning was that the principal value which will come must be present in this pi by 2 to pi by minus pi by 2 to pi by 2. Okay, if the value was higher than the minus pi by 2, or the value was higher than the pi by 2 and lesser than the minus pi by 2, we would have to subtract the value. Okay, now let's have a look at the second example, but before that, pause the video to note it down. Okay students, let's have a look at the second example of this 2.1 intro, which is find the principal value of cot inverse 1 minus 1 by under root 3. Find principal value of cot minus 1 by under cot inverse minus 1 by under root 3. Okay, we need to find out the principal value of cot inverse minus 1 by under root 3. Okay, so let's have a look at the solution. First of all, let us consider cot inverse 1 minus 1 by under root 3 equals to y, and y belongs to 0 to pi in this curly brackets in this. Okay, our next step is to take minus 1 by root 3 here and take cot inverse here. We have cot y equals to minus 1 by root 3. Now look at which values 1 by root 3 present. 1 by root 3 is present at the pi by 3, minus pi by 3 equals to cot y, and now we need to subtract this value from pi, because if we will subtract this cot from pi, we will have cot, we will have the principal value which will be lying from the 0 to pi. Okay, now let's subtract pi minus pi by 3. We have 2 pi by 3 equals to cot y. Okay, this was the main thing. Now we should see whether the 2 pi by 3 value is coming from 0 to pi or not. Do you know why I have subtracted pi from minus pi by 3 from pi? Because we need to get the value which was lying from 0 to pi, and this value is lying from 0 to pi. That's why I did so. This was the exercise 2.1 intro of class 12th mathematics inverse trigonometric functions, and thank you for watching this video. And if you like this video, please hit the like button and subscribe my channel. Okay, thank you for watching this video again.